Now we are going to the course Laplace Transform. Laplace Transform is a great mathematical tool that is used to solve harder differential equations. We all know that differential equation is used everywhere. In fact, in electrical circuits, in electronic circuits, in digital signal processing, in system modeling, in radioactivity. In these cases, harder differential equation is seen and we have to solve harder differential equations, and Laplace transform gives us the easier way to solve those kind of differential equations. Let's now look at a flow chart to show that how Laplace transform works. First, harder critical or harder differential equation we face, and then by Laplace transform we will convert it into easier or simpler equation with polynomials, and then we will solve it, solution or solve, and we get result, some kind of results, and then we will apply inverse Laplace transform, and we will get differential equation. So this is the workflow of Laplace transform. So Laplace transform converts differential equation to easier, simpler equations with polynomials. Okay, now let's go to the definition of Laplace transform. Now we'll go to the definition of the Laplace transform. Laplace transform equation should be f of s, that means function at s domain, equals to integral from 0 to infinity e to the power minus st f of t with respect to t. This equation is called the Laplace transform equation. Okay, where these functions is in the domain of t, function in the domain of t, and this function is called input function. This function is called the input function. Here we input functions and we get the outputs by an integral. This is a definite integral from 0 to infinity. This output function is in the domain of S. Why there is no time domain? Because when you apply the limit, or plug in limit 0 and infinity, there is no t variable in the site. So only s will be present and the function will be in S domain. Okay, so this is the definition of Laplace transform. we can alternatively write this symbol. If we write this symbol, this will denote Laplace transform of f of t, then it will mean 0 to infinity e to the minus st f of t dt. So these equation and these equation is very much the same thing. Now in some books S is not used. A, B, C, various symbol is used some books in place of S. So we can conclude that f of s equals to Laplace of function in t domain equals to 0 to infinity e to the minus st f of t dt. Okay, now example. Now let's see examples. If we write Laplace transformation of sin x, sin t in fact, sin t, then it would mean integral of e to the power minus st into sin t with respect to t from 0 to infinity. Okay, if we write Laplace transform operator of e to the power twice t, so the integral should be e to the minus st into e to the power twice t from 0 to infinity. Okay, here we write in fact Laplace operator in this technique.